Hello students, how are you? I am back again with another video. This time I have taken questions from magnetic effects of current and current electricity also. These questions have been asked in the morning session of 25th January 2023 JEE MAINS. So without wasting time, let us discuss one by one. Here comes the first question. It is a matching type question. List 1 gives you different configuration. Configuration means arrangement of current carrying wires, and list 2 gives you the corresponding magnetic field at point 2. So again, as I would always suggest you that go on solving only as long as you find the options similar. The moment you get a different option, you can immediately conclude what is the correct answer. So no need to, you know, solve for all the four options because all the different options are different. Not all the four options will be similar, no, in all aspects. So just maybe you have to obtain the uh, you have to match only for A and B, I guess. Just two will be enough. So let us match A. So in A, see, in these kind of questions, the best piece of advice will be to subdivide all the things into circular arcs and straight parts, because we have only two formulas other than solenoid and toroid and all. We have only two formulas, one for straight wire, another for a circular wire or an arc. So I'll do one thing. I'll take the straight wire as AB. So B due to AB, B due to AB. So for a straight wire, it is mu 0 I by 2 pi r, where r is the distance of the point where we have to find from the wire. We can take this as a continuous wire. And if you apply proper rule, Ampere swimming rule or Maxwell's corkscrew rule, okay, or even right hand thumb rule, you'll find that it is along the outward normal to the plane of the page. Then this circular part, I can take it as C for circular. So B due to circular part. For a complete circle at the center, it is mu 0 Ni by 2r, and it will be along the inward normal to the plane of the page. So net magnetic field will be the difference because both are in opposite directions. So you have to get the difference. So BC minus BAB, larger minus smaller. So this will be mu 0 I by 2r, you can take common. This will be 1 by pi minus 1. Sorry, 1 minus 1 by pi. So we have mu 0 I by 2 pi r into pi minus 1, and the net will be in the direction of bigger one. So bigger one is along the inward normal. So 1 A should be mapped to this pi minus 1, A to 3. A should be mapped to 3. So A is being mapped to 3 in two options, 1 and 3. Let us explore one more thing. We can solve for B or C, because D is also similar for in both the options. So either we can solve for B or C. Okay, so I'll solve for B. B or C, anything is it. Let us take the case of B because we have only one straight portion and one circular portion. This straight portion magnetic field will be zero, circular portion it will be there, and also for the straight portion. So I'm calculating for C magnetic field. Magnetic field due to the straight wire will be 0 AB because point lies on the axis here. Magnetic field on the axis of the wire is always 0. Then B due to the semicircular part will be half that due to complete loop. Complete loop it is mu 0 I by 2R. Okay, and its direction is along the inward normal to the plane of the page. Then you have B due to the straight portion. It is a semi-infinite wire, you can see. So for a semi-infinite wire, it is mu 0 I by 4 pi R. It is along the inward normal. So net field will be to add. They are in the same directions, just add them to get the net field. So here you have mu 0 by 4 pi r into 1 plus pi, that is fourth. C should be mapped to fourth. That is third option is the correct answer. Okay, because C is mapped to fourth. Then coming to the next question, a solenoid of 1200 turns is wound uniformly in a single layer on a glass tube 2 meter long and zero point 0.2 meter in diameter. The magnetic intensity at the center of the solenoid when a current of 2 ampere flows through it is. Here students, we have to find the magnetic intensity or the H vector of the magnetic field. It is also known as the H vector of the magnetic field. H vector is given by P by mu. If it is air, it is mu naught. We all know that in a solenoid, the magnetic field at the center, magnetic field at any point on the axis is given by mu 0 Ni, where N is the number of turns per unit length, I is the current through each turn. Okay, so when you substitute the values, mu naught gets cancelled. Since it is air, I have taken mu naught. Nothing is mentioned, so we have to take it as air. So number of turns per unit length. Over a length of 2 meters, there are 1200 turns. So number of turns per unit length will be 1200 by 2, and current carried is 2 ampere. So we have 1.2 into 10 power 3 ampere per meter. That is the second option. Then moving on to the third question. As you can see, in the given circuit, the equivalent resistance between terminal A and B is. So when you connect a cell between terminals A and B, you will find that the current will go through like this. But as soon as it reaches here, see students, very important thing, the entire current will pass through this because basically these 2 points are short circuited. So here actually the current is supposed to go like this in these three situations. But since a resistanceless path is already available, so no current will flow through these resistors. So the situation will become something like this. You can remove them because no current flows through them. Simply remove those resistors because there's no point in keeping them. So this is the situation. As you can see, these two are in parallel because this common point, the ends are connected to this common point, and these two ends are connected to these two common points. So 2 and 2 in parallel will be 1 ohm, and this 3 ohm, this 1 ohm, and this 6 ohm are in series. So in series you add them to get the effective resistance. So 3 plus 1 plus 6, that is 10 ohm. So 10 ohm is the correct answer, correct option. So I hope you are getting this. So whenever a short circuit is available, a resistance less path is available, the entire current will flow through the resistance less path. Then moving on to the fourth question. Uniform metallic wire carries a current 2 ampere. Sorry. When 3.4 volt battery is connected across it, sorry, the mass of uniform metallic wire is this. Density is this. Resistivity. This is simply based on the fundamental formula for resistance of a prism. Resistance across a prism. Resistance across a prism is given by rho L by A, where L is its length, A is the cross sectional area, and rho is the resistivity of the material. Now we can find the volume. From volume we can replace area. Area can be written as volume upon length. Area of a prism is volume upon length. So let us calculate the volume here. Volume will be mass by density. What is the mass given? Mass is 8.92 into 10 power minus 3 kg. Density is 8.92 into 10 power 3 kg per meter cube. So total it is 10 power minus 6. So now resistance you can calculate by voltage by current. So resistance is 3.4 by 2. Rho is given as 1.7 into 10 power minus 8. Length square by volume. Volume is 10 power minus 6. So as you can see, 2 into 1.7 and 1.7, 1.7 gets cancelled. You have L square is equal to 10 power minus 8 becomes plus 8. So this is, so L is equal to 10 meters. Okay. L square will be 10 power plus 8, and this 10 power minus 6 goes to that side. So that is 10 power 2. So 10 meters is the correct answer. So that's all in this video. Thank you so much.